Welcome to the walkthrough, the work solutions for the Edexcel iGCSE. As you can see, they haven't put the date on the front again, still sort of the tail end of COVID, but it's paper 2R for the higher, and we're talking Jan 2022, so let's go. At the beginning, bog standard probability, all load of waffle, adds up to 1. That's all you need to know, so grab your calc. 1 minus all the rest, they all add up to 0.78. So a nice easy starter. And work out the probability either, which means add them together. So we've got 0.24, 0.16 for 0.4 for a cracking 4 marks starter. Whoops. Number 2, bit waffly, bit overcomplicated, but I get what it's doing. 2020, save that total. 2021, not given the total, so work it out. It tells you per month, so get it multiplied, start picking up your ticks. Once you know that, it says work out the percentage increase. This is just a posh way of saying work out the percentage increase. Well, percentage increase is actual increase. Do a subtraction, divided by the original amount, multiplied by 100, giving you another nice 4 marks. It's a 30% increase. Part B, standard comparing two different things. Split your thoughts, just crack on with one side of what's going on. So if we use coupon A, it's going to cost you full price on the flights, but not full price on the accommodation. You get 18% off. So your multiplier is 0.82. So that comes in at $2,112. Let's do a similar thing for B, but it's total cost of both. Adding them together, 2,400, and to get a 12% discount, your multiplier is 0.88. We need to go a little bit more. It's 0.875. And if you're not great on doing your multipliers, I'd always say, think of that as 12.5 pence. So it looks like that. And subtract it from £1, and that's how you get your multiplier. But it turns out to be £2,100. There we go. Which of the two coupons should he use? It's definitely option B. We saved $12. Number 3, standard inequalities. Treat it like an equal sign. Do the same to both sides. So the 4y stays, but we subtract 5 from both sides. And now we divide both sides by 4. You could go mixed fraction or decimal, no one cares. Solving, we hate that divide by 2. Get rid of it by doing the opposite. Multiply both sides by 2. So the left-hand side, everything doubles. The right-hand side, nothing doubles, but the bottom disappears. So technically it doubles, but you know what I mean. Isolate the x's. There's more over here. So I'll subtract 4 of them from both sides, while at the same time adding 10. That means we need to divide both sides by 8. And again, I'm going to go for fractions rather than decimals. Number 4, I've done the full decent quality working out on my worked answers, so go and check them out. Here I'm just going to talk you through them. The sneaky bit is they share a side. So these are the same. So that is also x. Now we know that, we can crack on with internal angles. So when we do the octagon, internal angles, you subtract 2 from the number of sides. You multiply it by 180 to find what they all add up to. And you divide by 8 because there are 8 of them. And we always get 135. And if you knew that off by heart already, you can just quote it and go straight to it. Similar process with the regular pentagon. Take 2 away from both sides. You get 3, and that gets times by 180, divided by 5, and you get 108 for that. Why does all that help? Because let's focus on the apex of this isosceles triangle. The 135 is the big part. The 108 is that part. We'd like that part. We just subtract them. So that little angle here, that's 27. And the formula, the method, whatever you want to call it, to find the base angles which are equal, do 180, take away the angle at the apex, and because they're equal, divide them by 2. So we get one of those rare occurrences where we get a 0.5 for an angle question. That's not Socotel or anything. Anyway, number 5, standard waffle. It's always saying, oops, so nearest dollar for the answer. Capital. Like I said on question 3, was it? You multiply for 2.5%. Basically, that's 2.5 pence. So start with your pound and add on 2.5 pence, because that's how you get to your multiplier if you're not a fan. 3 years, power of 3, $7,753. Is it dollars? It's dollars. 0.6 and so on. So 7754, and on we go. Standard, again, lots of standard stuff here. Anything to the power of 0 is 1. Part B, multiply means add the powers, so -3 plus 9 gives you 6. Not so standard for C. You could just go straight off the bat and do it as 206 plus m minus 2 and so on. I decided I'm never a fan of fractions in these kind of things. So it's just for personal preference. I multiply both sides by 7 to the power of 214. And now, because these base numbers are the same, left-hand side, we can add the powers. Right-hand side, we can add the powers. And hey presto, you get m to be 5. Number 7, they're giving you all the information. It's just a case of reminding yourself. Straight line looks like that. And telling you it crosses at 0, 5 is just a posh way of telling you the intercept. So it's y equals minus 3x plus 5 for an easy couple of marks. Part B, as always, I don't trust myself with my electronic pen, so I've drawn these lines on. Let's remind ourselves of where we get them from. So the line x equals 6, don't forget, another name for the y-axis is x equals 0. So x equals a number is a vertical line through that number. Same logic for y equals 2. Another name for the x-axis is y equals 0. So x equals 2 goes through 2 and it's horizontal. And for the diagonal line, y equals mx plus c. So it crosses at 1, and because the units are matched on the x and y, you can go across 1 up 1 and diagonally, and there we go. Now for the inequality, where horizontally is lower than 6, it's to the left of that line. Where vertically is bigger than 2, it's above that line. And here, not so easy, but let's just read it as where is the height, that's the y, less than the line, that's under it. There's your R. Shade it in if it makes you happy. Number 8, we've got a good old scientist question, but who cares? It's one of those mean questions, not as in mean as in mean average. We don't know a specific bit of info, but we do know totals. 50 tigers, mean of 218, means total weight of all the tigers is 10,900. We know the total weight of the Siberians because we multiply them. And then once you've got all that, it'll be equal. I'm not going to fill it in, that's your job. You divide by 28. I think you get 5,180. You end up with divided by 28 to get a good solid looking 185 kilograms. Number 9, what a weird hidden SOHCAHTOA question, but that is what it is. It's basically asking you to find AC, subtract F to D, and that's 6, and add on the semicircle. So first job is find AC, that's the hypotenuse, 24 is the adjacent, so we kick off with a CAH, part of SOHCAHTOA, we're after the hypotenuse. So to get AC, we do adjacent divided by cos of our angle. And if your calc does surds, leave it in surds. No point in going to decimals unless you have to. Then let's look at the semicircle. The formula for a circle is 2 times pi times the radius. But we've only got half of it, so let's halve it. Again, 3 pi if your calc lets you. So we're there, aren't we? You need to do AC, which is 16 root 3. Subtract the 6, because that's been chopped off. But then, so subtract 6, but then add on your 3 pi. You should end up with 31.1-ish. But we're told 2 sig figs. Hate it when that happens. I fat fingered it. There we go. And so it should become, oh, we didn't use up all their space. It should become 31. Next. Number 10. It's a posh standard form question. Now to find out per person, you're going to need to divide by the number of people there are. So you need to press Austria total spent divided by number of people. Stick that in your calc, be careful with brackets, and you should be getting 5,873.01 whatever. For Luxembourg, same. Total spent divided by number of people should give you 4,827.58 and so on. And it says how much more. It's pretty obvious. the number on the left is the biggest. So you need to take them away. In fact, I've got them the wrong way around, haven't I? Do apologise, folks. The 5873 is actually Luxembourg. All right, and that is Austria. When you subtract them, you get 1045.4. We're told nearest whole number. Always do as you're told. Next, number 11. Yeah, I had a nightmare on this, but never mind. If you need to, use your calc, substitute in, find the gaps. 6 divided by a half is 12. 6 divided by 2, 6 divided by 4. Now it gets a bit harder to plot. We get 1.2. Yeah, I did indeed put that first mark in the wrong place, but who cares? I got there in the end. Plot all those coordinates, and please make sure yours is better than mine. I had a wobble, and yeah, I do it in Biro straight away so it shows up when I scan it. It's not my worst effort, but it's certainly not my best. Number 12. I've not drawn anything on here just to talk through the logic. Work out the angle of depression. Now let's not forget where that angle is. So if we draw a horizontal line from D and down and along, yes, it's heading down the Sokotoa or whatever route, but before we get there, it's the idea that these lines are horizontal and therefore parallel. If this doesn't illustrate why they're called Z angles sometimes, but alternate angles are equal. So the angle of depression there is the same as that angle there. So there's your X. Next job, good news. We know the adjacent. It's 244. We don't know the hypotenuse, but we can work out the opposite because it's 30.7 minus the 6.2. We're getting 24.5. So I'll repeat, we've got the adjacent, we want the opposite. We're cracking on with TOA. You want the angle, so to find X, inverse shift second function, whatever your calc's got. Opposite is 24.5. Adjacent 244. Again, be careful how you put in your calc. Fraction button pays off for me. All that spits out 5.73-ish. So to one decimal place, 5.7. Number 13. What a strange one. But it is what it is. Don't get put off by things that look different. What is A? Take away B. Well, here's A. Now, if I subtract B, it means I'm subtracting a root 8 and I'm subtracting a minus 4. Minus of a minus is a plus. When I add these two, I get 2 root 8s and the 4s cancel out. So I'm really getting 8 multiplied by 2 root 8, which is really 16 root 8. But take care, don't applaud yourself just yet, you haven't finished. It's saying that the number here that's times by 4 in the surd, in the radical, needs to be the same as the number here. Now you could, if you wanted to, use law of indices, because really that's root 4 and so on. You've got y times y to the half. So you could try and do that. I just did a little bit of trial and error. If you stick 16 root 8 in your calc, hit equals, it will spit out 32 root 2. That doesn't help. It's not the answer, but it does mean you need to look elsewhere. Where is that elsewhere? Little clever bit. 16, another way of writing 16 is 8 times 2. But I'm going to write the 2 in a stupid way. I'm writing the number 2 as the square root of 4. Why does that help? Because that means you can take the 4 inside. It's basically simplifying a surd in reverse. You're making it more complex, basically. But there's the key. Those two things are now the same, and the 4 is what you were told. Job's a good one. Y is 8. Number 14, I've got to say, if you did this question like I did, it felt like it was never going to end. I've been teaching 24 years, tutoring for 3. I've got to say, I've never seen a cumulative frequency graph where 5 lines were needed. So let's take a deep breath and let's go for it. So A wanted the median. So you draw your line at 30. So I got 48 for mine. Mark's scheme allows to be within 1. So Mark's scheme, let's get rid of my horrible 8. Mark's scheme allows 47 to 49. Here comes part B. Less than 58. So there's my 58. There. Up and along. It's my top line here. As you can see, I've slightly cut it off. I get mine to be 46. Now, a lot of the times they want it to be greater than, but not this time. They're looking for lower than, which is why your answer is 46 and not 14. I'll stay on this page because part C wants the interquartile range. So lower quartile is at 15. As you can see, mine looks like 40. Upper quartile is at 45. As you can see here, mine looks like 56. So 56 take away 40. I get 16. Mark's scheme allows 16 to 18. And then we crack on. Why not do some words? So in the wordy bit, the IQR is 9. We've just found the IQR. Well, I got 16. Is he correct? He is absolutely correct. And you need to write a sentence. I'll just write, because the algebra interquartile range is bigger than the geometry interquartile range. That's all you need, nothing fancy. Part E. We've got to go back to the graph, because a grade A is 64 or above. So another line. There's the 64. We go up. I get 50 students. So that means students who get an A, or what was it, a grade? Yeah, grade A, are these 10 folks up there. So the probability that a student picked at random is 10 out of 60. Use the graph to find an estimate that both students picked. So if you pick one student and you've got them, next time you pick a student, there'll only be 9 of them, and there'll only be 59 students. Calc says 3/118, and we can finally move on from that. It's not a nightmare and it's not difficult, but 8 marks for cumulative frequency? Yeah, hated it, but let's move on with our lives. Number 15, a bit more meat on the bone for these than usual with the n squared and the t cubes, but just crack on as normal. So get them all on one level by multiplying both sides by t cubed. Numerator remains the same. And as always with these, if you want to make t the subject and there's more than one of them, you need to isolate them, which means get them onto one side. I'm going to subtract t cubed from both sides. Now, if you chose to get them on the right-hand side, it simply means your answer will look like mine, but all the pluses and minuses will be swapped to the other one. Mark scheme allows both, so don't panic. Factorise out a t cubed. You'd be left with n squared minus 1. Divide both sides by the brackets. And we're nearly there. To get t on its own, you got a cube root. Can't leave it with the cube in. Normally these are worth 3 marks. That extra bit of flaff going on, is that a word? Means, whoops. That extra bit of meat on that bone means that it's worth the extra mark to make it 4. Number 16. You can tell straight away it's double trigonometry. You're going to need 2 skills. Slightly backward though, in that you don't know enough about this triangle. So you need to work it backwards to find that. You've got a formula, half AB sine C equals the area. So we'll set that equal to a half times the 36, the 45, and the sine of the angle between them. If you work all that out and then do 405 divided by it by some fluke, you end up with 0.5. In other words, the angle is 30 degrees. That's nice. We can now progress to the standard, which is when you've got 2 triangles, the usual target is get the common side. So before you even worry about what comes next, you need BD, because that's going to help you on the next step. And we've got an angle and the sides, either side, it's cosine rule. So BD squared equals these 2 sides squared and added. Take away 2 lots of these sides multiplied by the cos of the angle. Now, when you stick all that in your calc, you should be getting 515-ish. 0.77 to be a bit more precise. So by the time you've square rooted, we're talking 22.695-ish. If it was wanting 1 decimal place, I always work in 2 or 3, so it doesn't have a knock-on effect that your answer is a bit too far out. Now you know this side. Work out the size of angle ABD. We'll call it Y. When you want an angle, you don't know an angle and its opposite side. It's the cosine rule. Still can't use the sine rule, but it's the cosine rule rejigged. The rejigged version is the 2 sides either side, that's 19, and the one we've just found. So it's the adjacent sides squared and added minus the opposite side squared all over 2BC. And don't worry, what these A's and B's don't matter. You're ignoring them. 2BC means 2 times the angles, 2 times the sides either side. So it's the 22.695. All that in your calc should be giving you 0.10675, whatever. But that's not going to be your answer. Reason? Because that's what the cos of y equals. as within all trig, if you want an angle, it shifts cos and so on, or second function, or whatever. I get 83.87. So 83.9 it is. Number 17, I've done the cheeky and, as you can see, drawn my tangent on already. You can draw it bigger. I wouldn't advise any smaller. I'd say that's, just slightly undersized, but it's fine. I like it where it meets things, which makes it easier to read. If the base of your triangle is floating or down here, it can get a lot trickier. So by doing it my way, you are making sure that the numbers are a bit easy to read. For example, the height goes up to the first little baby square. That makes it 2.2. The width, it's nearly 2, because it nearly goes from 1.5 to 2.5, but it's not quite. And to find the gradient, it's the vertical divided by the horizontal. So for mine, I get 2.4 recurring, which I rounded off to 2.4. Mark scheme's pretty generous. It allows anything from 1.5 to 3. So if you're outside that, I'm afraid you've really drawn your tangent quite badly. Number 18, it's our old friends, simultaneous equations. Slight difference from the norm is that, as you can see in the equation, they've put all the y's on the left, x's on the right. Now, I'm never a fan of trying to do y equals x plus 1 over 2. Substituting in fractions is, for me, very tricky and should be avoided if possible. So I'm going to take away 1 from both sides. And that's the substitution. That's the replacement I'm going to make. So the left-hand side of this will remain the same. It's the right-hand side which will become 2y minus 1 all squared minus 2y minus 1. So I'm not going to rewrite that, can't be bothered. Let's expand and simplify the right. So we get 4y squared, square the first, square the last, times the 2 together and double it. And a minus in front of some brackets means minus 1 times. Or another quick way, change all the signs. So if you tidy all that up, 4y squared minus 6y, you've got a plus 1, and sorry, not a minus 1, I said it and I didn't do it myself, minus 1 times minus 1, do apologise, it's a plus 1 on the end, don't be as daft as me. So we end up with plus 2, and that equals the quadratic I couldn't be bothered writing on the second line. So we've got more y squareds on the right, so we'll get our y's to the right-hand side, subtracting 3y squared from both sides, minus 7y, and minus 16. Gives us a quadratic, which is nice, because it factorises. We get y minus 14 and y plus 1. So our two answers for y's are 14 and minus 1. We just need our x's. And I'll just scroll up to have a peek to remind ourselves x equals the y ordinate doubled and then subtract 1. Double 14 is 28. We subtract 1. Double negative 1 is negative 2. And we subtract 1. We're done. Number 19, again, I've added on a couple of lines to save mucking around with technology. Not the worst 3D trig in the world. Not a bad one, if I do say so myself. That's the angle you're after. You already know the opposite side. It's one of the other two sides, and you certainly don't know enough to find EC, but you do know enough to find AC because it's the hypotenuse of a rectangular field. So we can say that AC is the square root of the two shorter sides, squared and added. And don't go to decimals unless you have to. Calc keeps it in surd form. Now, one of my bits of advice with these 3D trigs is it does help sometimes to redraw a triangle to help you see whether it's sock, cat or toa. So there's our angle. Opposite, adjacent, it's a toa. And it's opposite divided by adjacent. Calculator says 31.35. That'll be 31.4 then. Number 20 is quite a tricky, but don't give up on it. One way you've got to do connected proportion, in other words, sub one into the other. What does the top line tell us? Y is, come on pen, Y is inversely proportional to root x, and the second line, x is directly proportional to t cubed. So basically, that's going in there. So our new formula will be y equals c divided by the root of kt cubed. Now here's the logic. It only tells us that y is 8 when t is 25. There's a c and a k, there's two unknowns. Here's the logic. What is an unknown number divided by the root of an unknown number? Answer, it's an unknown number. So let's combine all that rubbish with a variable so that we only have one. Because as I say, something you don't know divided by something you don't know is something you don't know. Easier to have one thing you don't know than two. Now you can replace the y with 8 with the with the square root of t cubed. So what does p work out to be? 8, well, root of 25 is 5, cubed is 125, and we times it by 8. P is 1,000. Magic, because you've now got your equation. Y equals P divided by the root of t cubed. Now we can insert that y is 27. So 27 equals P over the root. And the quick way of rearranging these is times both sides by the root of t cubed, divide both sides. Oh, hold on, sorry. We know that P is 1,000, that helps. So these two, you can essentially flip them around. Take the root of t cubed to the top left and take the 27 to the bottom. And now find your t by doing opposites. So stick the 1,000 divided by 27 in your calc. Get rid of the square root by squaring it. And whatever your calc says, get rid of the cubed by cube rooting it. It should spit out the nicer looking 100 over 9, or the equivalent of. Number 21 looks horrible, reads horrible. Trust me, it's not the worst question in the world. All this waffle here is in the diagram. One by one, it's there, it's there, it's there. What you need to realise is the total surface area of the solid is 81 pi. So 8, I'm going to do it up here because there's loads of waffle. 81 pi equals the entire surface area. Well, let's list it. The entire surface area of this shape, it has a circular base. That's pi times the radius squared. Now, when you unravel a cylinder or the label of a soup or baked bean tin or whatever, it's a rectangle. And the area of that rectangle, that distance is the circumference, and that distance is the height. So get these two things multiplied. That's 3 times 2 is 6. We've got a pi, and we've got an x times the radius. Well, x is the radius, so it's x squared. And we've got the surface area of a hemisphere. Flick back to your formula page. A full sphere is 4 pi r squared, so half of it is 2 pi r squared. Well, blow me down if the pi's don't cancel. Divide the left-hand side by pi, divide the right-hand side by pi. And look how simple it's becoming. I'm going to go down here. So the 81 equals 1x squared, 6x squared, 2x squared, or in other words, 9x squared. Divide both sides by 9. And square root, obviously, because it's a length, we ignore the negative. In other words, people, you know what x is. Now we can move on. I hope it's obvious. It now becomes a density, mass. We need the volume. It's one of them questions. So let's have a bit of space. The volume of this shape, well, the top is a hemisphere. So that's half of a sphere. And flick back to your formula page. A sphere is 4/3 times pi times the radius cubed. We can smarten that up in a sec. The formula for the volume of the cylinder. It's pi multiplied by the radius squared multiplied by the height, which is 3x, so 9. Now, if you ignore the pi's and do the rest on your calc, or just stick it all straight in, however it gets there, you get 99 pi centimetres cubed for the volume. Now all we need is to work out the density. dmv, density is mass. That's 840. I'll squeeze it in here so we can still see the table. Density equals mass divided by volume, 99 pi, and you get 2.700. Boom! It's got to be the aluminium, or if you're in America, aluminum, but notice how it's spelled, please. Aluminium. That's the correct spelling of aluminium. Aluminium. Number 22. Not the nicest of questions. Lots going on. Lots of room given for what will become obvious. Loads of room. Always draw yourself a diagram. It helps you picture the problem. The diagram does not need to be accurate. It does not need to be any good. It just needs to help you picture the problem. And that's all I'm going to use it for. So it tells us that ABC is 90, so the right angle is at B. A is the coordinate P, 10. B is -1, -5, and C is 8, Q. We know that the gradient of this line is -6/7. Now, ultimately, folks, you've got a P, you've got a Q. That's two unknowns. You have equations that you can come up with. Now, this question can be done using Pythagoras, but I've opted for the coordinates and gradients method. But ultimately, it boils down to two unknowns. You're going to need two equations. In other words, it's a simultaneous equations question. But getting the two equations set up is very difficult. But let's do it. The gradient of A to B, so it's changing y's over changing x's. So it's 10, take away -5, P, take away -1. Now let's do the gradient of BC. Again, changing y's, so let's do Q -5, and changing x's, 8 -1. Now we know they are perpendicular, which means we know that when we multiply them, we get -1. So now I will scroll back up. Let's tidy this up so it looks like a proper equation. I'm going to multiply both sides by 9 and then by P plus 1. So -9 times P -9 times plus 1. And here 15 times Q plus 5. Let's expand those brackets. 15 times Q, 15 times 5. And let's tidy it up a bit. 15Q plus 9P. Subtract 75 from both sides. And they're all in the 3 times table. It's always nice to have them in as simple a form as possible. Boom. You've got one equation. Where are we going to get the other equation from? They've not told us this for nothing. How do you work out the gradient of A and C? Again, change in y's over change in x's. So 10 take away Q divided by, keep the order, it's important, P minus 8. That's how you find the gradient, but we already know what the gradient is. As you can see, people, this is our second equation. Let's multiply both sides by 7. And both sides by P minus 8. Don't forget it's a -6 times P and a -6 times -8. And again, let's get it in the same form, Q's and P's on one side. But I actually am going to add 7Q to both sides. So I do like to maintain the same order and subtract 48 from both sides. You have your second simultaneous equation. You can now ignore the context because all it asked you for is to find P and Q. So you can go about this any way you want. It's entirely up to you. But the way I did it on my worked answers, I called that equation 1. I called that equation 1 and I double it. So I get 10Q plus 6P equals negative 28 doubled is negative 56. But I kept this one the same. I'm just going to write that bit on the left-hand side. And so the 22 on the right-hand side. And as with all simultaneous equations questions, same signs subtract, different signs add. So 17Q, the P's disappear, negative 34. And it's worked out lovely. Divide both sides by 17. We get Q to be negative 2. Pick one of your other equations. All right, pick any of your two equations, really. I think I'm going to go for that one. So rewrite it, except stick your Q in. So I've got my Q. 5Q is negative 10 plus 3P is minus 28. This now needs solving. So we shall add 10 to both sides, dividing both sides by 3. Can't believe that's only 5 marks. Should be about 15, if I'm honest, but there we go. It is what it is, and it's a tough one. And finally, composite functions, but also inverse functions. Before you even try to find the inverse, find the function itself, which is, it's the f of g of x, which means the g of x needs to go in and replace x in the function for f. That means you'll get x squared minus 12x in the place of the x. That's a hell of an x, Al. Well done. But there's also plus 25. And whenever you're trying to do inverse functions, I'm sure your teachers said, call it y. Now your job is to essentially make x the subject. Can be done using the quadratic formula, but no. When it's a quadratic, complete the square. X, halve the number next to x. What the heck am I doing? I'm doing the thing that I always tell students not to do. I did it, folks, so you don't have to. And so we've got x minus 6 all squared, and that ends up at negative 11. And now we can proceed to make x the subject. So let's add 11 to both sides. Then we'll square root. I'll come back to that in a sec. Now to complete the job, add 6 to both sides. I'll just flip them around. And there we go. And I'm sure your teacher will have said, at the end of inverse functions, you simply flip them around. X becomes y, y becomes x. Y plus 11. What am I doing? X plus 11. But here's the doozy. The domain x is less than or equal to 6. In other words, domain and ranges, they flip about, but long story short, this whole thing needs to be less than 6. When you square root something, the smallest it can be is 0. So we don't want to be adding anything. So it's only the minus that we care about. And there we go. Couple of right doozies to finish off with. Right stinkers, got to be honest. But as I said quite early on, about 40, 50 minutes ago, there was some good questions right at the beginning. Standard, standard, standard. This is all right. This is all right. So plenty of marks to get your teeth into. Never let the last few questions put you off, no matter what grade you're aiming for. Some of you might just abandon these late questions entirely. It's perfectly legitimate. Spend your time on the cumulative frequency questions, which was worth 8 marks. That's a big one. Those who are aiming for the grade 8s and 9s, come back to these. Make sure you do at least pick up 2 or 3 marks. It's not essential you maximise. It's not essential you smash every mark. To get a grade 9, you don't need 99% or any nonsense like that. You can drop marks and you'll be fine. Anyway, time to shut up. I hope that's helped, and I shall see you on the next one.